Okay, this is Rike. With Rike, we work together at the same institute. We work at the Bernstein Center of Computational Neuroscience. I attended a school, a Python school in Croatia. During the school, we had to do this assignment. This assignment was this Pelita game. Pelita game is like a game like Pacman. So you will have a look. Rike will just introduce you to the game and have a look. And then the idea is to split into teams and working groups, develop our own team, our own, let's say, our own strategy, and then play the teams against each other.
Let me just explain a bit on how it works. So you play against either another team or against a computer-generated team. Each of your teams owns 2 bots, and in our naming scheme, each bot is controlled by a player, and the player is basically the algorithm which moves the bot around. There's a harvester and there's a destroyer bot, depending on which side the bot is on. So if the bot is on their own side, if it's the same color as the pellets around it, then it's a destroyer, and then it can eat the other bot. So if the red one goes over, it may be eaten by the blue one, or the blue one on the right side can be eaten by both of the red guys. And yeah, when it's on the other side, it is a harvester bot, and it has to eat the food pellets. And yeah, the game ends when all food pellets are eaten, so it's pretty simple. This is the video. I can show short much, but if you have managed to install it, you've seen it already. It's also not really clear, it's a bit fast. So now the blue well, okay, this is a strange situation, of course, because did I put this video in? Because now the blue team has eaten all the pellets, but the red team has eaten more of has eaten the blue team a few times, so they got more points. They got points for eating it. So that's why the red team wins, even though the blue team finished eating all the pellets. Not sure if it matters today. A few rules. Yeah, when you eat a food pellet, it's permanently removed and you get 1 point. You basically only have 3 seconds for a move. I don't know if we have maybe we can increase this today if it's too harsh. When you eat another bot, you get 5 points, and after 300 rounds, or when all food pellets are eaten, the game ends. And the last thing, it's probably not really relevant. You can only see the exact position of the opponent when it's close. So when it's further away than 5 squares of you, it may be 1 or 2 steps off. But I'd suggest you don't care about this today. Basically, the only thing you have to write is a get move method. So you inherit from abstract player, or you just take the class which is there already. You rewrite the method get move, and you check for which moves are possible with self.legal moves, and then in this case we just take a random move from there and return this direction. You can also have a few other methods. So you can ask your current position, which bot you are actually, because yeah, you're in the player code, but you control the bot. Who are the enemy bots? Where's the food? Where do I have to go to actually? Current universe includes the maze object, which shows you where the wall is. Yeah, legal moves tells you where you can go possibly at this step, and the is_destroy method can run it on your bot or on the enemy bots in order to check whether they can attack you or you can attack them. In the init file of the module, we just return a simple team. So you just find this factory method, and then you can give your team a nicer name than the one which is provided. So this is a good thing to do. So when we run two groups here against each other, so we know who's who. In the main Pelita repository, in the players directory, there are a few other demo players. They're not really good, but they may just show you a few examples of how to use the API. So hopefully you don't need to read much else. How do you test it? For today, I say you test it by running the game and test by watching, because there's not really much time to experiment with the unit tests. Of course, you always should use unit tests, everybody knows that, but maybe not today. And yeah, for the tournament, we have a few time constraints today, so you just hack the code, tell us where you pushed it, and then every now and then we may clone your code and run a few games on the projector. Maybe. I don't know. Strategies. It's not too much time maybe to dive deep into strategies, but of course it makes sense to think about this, and then maybe for another meetup you can really have a finite state machine, the bot with 3, 5 or 8 different algorithms depending on the current situation, and then switching between those algorithms. Look ahead players also. You can also, for every situation, you can check for the next step, and then you have a huge function to evaluate, to give a score to the next situation, and then choose the direction with the best score. You can do something like that. I don't know, a few options. Mazes don't have dead ends. If you run away from one bot, it cannot catch you because they have the same speed. We like to see, always we want to have a strategy where the two bots working together and attacking the other guys on both sides. Can try it. Not sure if it works in 2 hours, but we believe in you. In the demo example template, there's a version which uses some shortest path algorithm in order to get the best direction. You can keep track of the opponents when they are noticed, and when you don't know the exact position, but maybe this is also too much for today. It's a bit too advanced. Reuse code every time, and think about how to work in a team. So you clone the Pelita main repository, you may fork the other repository, and then you run a game by calling Pelita game with the team module. There's also, Pelita game has a lot of command line arguments, and there's an online help, online documentation available. Okay, so now Galvanic player against Milita player, or B player against Lumera.
Okay.
For real now.
Okay. For real. Ooh. This
Okay, now braindeads against superstars. Okay, so B player against superstars.
To be fair, if everyone's yes.
Lumema against braindeads.
So like this is good
Our guy is
So Luminita player against who did you not play yet?
Superstars.
Superstars.
Now we're gonna get eaten every time shit.
Okay, on the last one, Galvanic against Pelita. Oh, B player against braindeads. Let's find out.
Right? Can you put Pietros afterwards?
Yeah. Oh, no.
Why is it so slow?
I think he generates a lot of data. I mean, usually during the school, all the games were that slow.
Yeah.
But basically, here you didn't have enough time to implement a slow algorithm. No.
We wanted to do this, but it doesn't work.
Okay, Guillermo.
Next meetup. Yes, I think there we go home. That was yours, Guillermo?
Yeah.
It's Monday.
This is 2 days of more work. And group 0, group 2. And 2 days.
Ladies, Meila Luma.
It's also slower.
Yeah.
Because they
So probably they're doing the shortest path on every time on all the points.
But these delays both players.
No, but it looks like it only.
you have 3 seconds. That's why they have the timeout. It's more than
3 seconds is okay.
Yeah. So this is
Oh.
Okay. Class dismissed.